Hello, everyone. I'm happy to be here today to talk about the ways you can use MyHeritage DNA tools to analyze and explore your DNA matches. In this session today, we will learn about some of the useful tools that you have available on MyHeritage, and we'll do it with real-life examples, many from my own account or from my colleagues' account, who were happy to share with us. We will also see how using each tool will move you forward with your genealogy research and shed light on the relationship paths that connect you and your matches. So what we are going to cover today, we will start from the basics, from the DNA results overview and the filters that we have. We will discuss DNA labels, one of the newest tools that helps you organize your matches. And then we will review all the components and information we have in our review DNA match page, like the very cool and informative theory of family relativity. And we will finish with a little more advanced tools like the Chromosome Browser and AutoClusters. So without further ado, let's start. So this is the DNA overview page where we summarize your results and show you different things like a summary glimpse of your ethnicity estimate and your DNA matches. But today we are going to focus on our DNA matches and how we can analyze them with all sorts of tools that MyHeritage offers. So from the DNA overview page, you can go to your DNA matches page where most of the work happens. So these are my DNA matches. And as you can see, by default, they are listed by the people who are more close to you. So first matches will be the immediate family, like father, brother, grandma, etc. And if I find a DNA match that I'm interested to learn more about, I'll go to the review DNA match page where we'll see much more information that will help determine how this match is related to us. So let's start with a new match I got. I received a new DNA match with someone named Josh Cohen, which I don't know. And I see he's in his 50s and is living in the States. And right here from the DNA match card, I have the option to contact Josh, since Josh is a member on MyHeritage and has taken a DNA test with us. So I can contact him if I want and ask questions, share information, and try to figure out how me and him are related. But I can also use the DNA information to figure it out. So here you see the estimated relationship, which reads in this case, great uncle or first cousin once removed to a second cousin. Now, some users are feeling more comfortable with what this means or what goes in that range. But if this comes a bit more complex, there's the question mark at the end of the estimated relationship, which you can click on, and then it will open a tree view, which will show based on the shared DNA, where this DNA match can fit in your family tree. So we can see the different options highlighted in purple, which fits the amount of the shared DNA that I have with Josh. Now, these results of the genetic data that I share with Josh, and they are also shown right here on the right, where in this case, I have 7.8% of shared DNA over 28 segments. And the largest segment that we are sharing is about 67.5 centimorgans. But we'll get to talk about segments and what we can do with them a bit later. At the bottom of the card is shown very useful genealogical information from Josh's tree on MyHeritage. So you can see here that Josh appears in a family tree on MyHeritage that he manages. And also there is some useful information such as Ancestral Places, which appear both in my family tree and in Josh's. And there are also smart matches, which indicates that MyHeritage found people that might be identical between our family's trees. You can also add a note about this match. So while you continue on your research, you can leave notes about important discoveries or reminder, and this is private, only you can see them. Okay, so let's go back to the list of DNA matches, and it sometimes can be very long, include thousands of matches. So filtering your DNA matches based on certain criterion can help you get those matches that you are interested in. So you can see here all the filters we have available. First, we have the filter that filters by the tree details, which will give you the option to filter by different genealogical facts, such as the people we found to have a theory of family relativity for you, which we talk about in a second, or the ones with whom you have smart matches, those with whom you have shared surname or a shared ancestral place. So the first filter is based on the genealogical information. Second filter allows you to separate your list by close, extended, and distant relative. So you can first look at the people who are more close to you based on the amount of DNA that you share. Next, we have filtering matches by their location, meaning where these people live today. You can also filter matches by their ethnicity results or by genetic groups. The genetic groups give you a higher resolution level aside of the percentage-based ethnicities, since this breakdown covers more than 2,000 geographic regions. And last but not least, we have the labels filter, which was added recently. So you can filter your matches by your own custom color-coded labels. The label feature helps you organize and quickly find DNA matches you mark as interesting, and we will shortly talk about it further. You can also sort your DNA matches list by different parameters, where by default they are sorted by the amount of shared DNA. So the closer they are, they will appear first on the list. You can also sort by the amount of shared segments, the length of the largest segment, by the names, or by the most recent matches. We are getting new DNA matches all the time. And by looking at the recent ones, you can focus on the ones that you haven't explored before. There is an option to also search in the DNA matches list by the name of the DNA match you want to. So if I type here Shmuel, for example, it will fetch all matches that have Shmuel in their name. Or if I'm looking for my DNA matches who are coming from Tsarfati line of the family, I can type it here as well, and all of the DNA matches who have Tsarfati in their family name will come back. So getting a new DNA match is always exciting, but the growing list of DNA matches can be overwhelming, and especially when we want to break through some of those genealogical brick walls, we need something that will help us manage the list. And as I mentioned earlier, this is where the DNA labels come to our help. DNA labels is a strong tool that we introduced a few months ago and is meant to let you organize your DNA matches in any way you want and get back to these matches you are interested in an easy and quick way. You can actually create up to 30 labels, giving them names and choosing the colors and assign them to matches. So you can easily find these matches by the areas you are interested in, like family lines, ancestor names, surnames, location, and anything else that you want. You also have the option to mark a match as favorite by clicking the icon right here. The match will be marked as favorite, and you can filter it by favorites matches afterwards. Now let's quickly see how we can work with the labels. Clicking the checkbox on the left of the match card opens the Labels Manager. Now I've marked a match that I'm interested in, and I can see his name on the left, and I see the list of labels that I created before, if there are any. They are represented by the name that I gave them and the color. So now I can choose to assign this match to an existing label by clicking the checkbox next to it. Now the checkbox is marked. And if I have a new criterion to add, I can also create a new label by clicking here. Once I choose that, a pop-up will open where I can name my label and give it the color that I want. For example, I want to create a new label, so I can assign the matches what I identify from the US. So I will assign the color that I want, I will name my label and click Save. Now I see my new label and it's automatically checked. And all I have left is to click Apply and the two labels are assigned. Now I'm back at my matches list and the match is assigned. Labels will appear with this colored circle on the right, what you see here. And it's very easy way to look for specific matches when I'm going through my list. Now, if I want to remember the label name, all I have to do is just to hover over this indication and I will see the full name of the label. Now, in the same manner we just saw, I can also assign labels to multiple matches at once. I can click more than one checkbox, so I can label 2 or more DNA matches at once. Once I check the label that I want to add, Levy family, for example, I click apply and I assign it. And the label was added to these matches. Now, I can also edit, remove, or delete labels at all time. When in the Labels Manager, when hovering a label, 2 icons appear. First, I can select to delete the label if I don't want it. Just notice that deleting the label will be removed. It means that label will be removed from all DNA matches that are currently associated with it. And I can also edit labels right here. So I can change the name or the color of the label into any color name that I want. In that case, the association of the label with the matches will still be remained. Now, if I want to remove a label from a DNA match without deleting the label itself, so it won't appear on the match, I can just uncheck the label that I want to remove and click apply. And as we saw earlier, the great thing about labels is that I can filter my list by labels or by favorite matches. So if I want to see only people from the Levi family or matches from a maternal side, I can just do it from here. Okay, so after we found the DNA match that interests us, let's go to the Review DNA Match page, where we'll see some more information that will help us determine how this DNA match is related to us. The Review DNA Match page is a long page, including lots of different tools and information to help you learn more about your DNA match. So let's start learning about each one of them. So this is my new match, Josh, and let's see what tools do I have to analyze this match. So first on the top of the Review Match page, I have my notes and labels that I can manage from this page, same as we saw in the matches list. I can mark this match as a favorite match. I can view and add notes for this match from here. And I can add labels to this match. So if I click on this icon, the label manager will open up. And again, I can assign or create new labels from here. And when I have one or more labels assigned, I will be able to view them from here, from this page as well. And this is an example of a different Review DNA Match page. And you can see that when you're adding more labels, when you're associated a DNA match with more labels, they will show up here. And again, you can add up to 30 different labels. And besides that, you are not limited in the number of labels that you can assign for a match. Okay, this is not the last from DNA labels, and this tool also expands to using it with shared DNA matches. So stay tuned. I will be showing that in a few minutes, and it will be very cool, I promise. So the first tool that we have in our DNA match page is the theory of family relativity. And this is a super sophisticated feature that helps you make the most of your DNA matches by providing you possible explanation on how you can be related to your DNA match by incorporating genealogical information from all of our collection that consists of more than 16 billion historical records and more than 85 million family trees to date. And it keeps growing. And it offers you theories on how you and your DNA match might be related. And we are updating the results every few months, so you are continuously getting new theories. So let's have a look in this example where we are Roman. And Roman has a DNA match called Emilia. By the amount of shared DNA, we can estimate that she is somewhere between first cousin to fourth cousin, but not much more than that. And we don't have any shared surnames or places that can hint more. But the theory of family relativity suggests an exact relationship that Amelia is a second cousin once removed to Roman. Based on the enormous amounts of data points we have on MyHeritage, we were able to link and suggest a relation between Roman and Amelia through this ancestor you are seeing here. So the summary of the theory is presented in the review match page, but for the full details, let's go to view full theory. Viewing the full theory allows you to see how MyHeritage established the relationship path and which sources of information were used along the way. Theories always begin in your tree and end in the family tree of your DNA match. And the sources of information that links between them can include historical records or other families' trees on MyHeritage. So we see here that Amelia is Roman's second cousin, once removed from the mother's side, and that are three different paths that lead to this theory based on different trees and records. So let's zoom in on our theory of family relativity, and we are going up in Roman's tree, up to his grandfather Kip, and then we have a hop. Every time you see a horizontal hop, this means that the theory is using a record match or a smart match that in this case to continue from one source to the next. The match is graded with the confidence level in percentage that you can see here based on the quality of the match. The higher the score, the better the match is. In this case, we found a smart match for Kip Solomon in Chromosome website, which has 100% confidence level. In cases you want more information about this match, you can click and review all the details from both sources. So I can look at the smart match and decide for myself whether it makes sense or not, whether I do believe it's the same person or not. And that will help me make the judgment whether this theory is correct or not. And then we are going up until our great-great-grandfather and mother in the Chromosome family tree, and down again to our great-great-uncle. Then we are making another jump to another family tree up until we get to Amelia's family tree. Since theories of family relativity are based on information that people put in their family tree, it can sometimes include incorrect or inaccurate information. So you can always decide by yourself if you want to confirm or reject the theory, so you can keep track of your DNA matches and theories. On the top of the theory of family relativity screen, you can choose whether to confirm or reject it. If you're unsure, you can leave it as is and go back to it later. And you can always change or undo your decision. Once you confirm the theory, it will appear with a confirmed indication. And we recommend to use the new path you just discovered and add it to your family tree. So you have an hyperlink to go to your family tree if you want to, and add this DNA match and the new information to your tree. All right, so the next tool that we have are smart matches. Smart matches are people that we found that exist in your family tree and in the family tree of the DNA match you are looking at. So we are looking at the data we have in each tree, and we're trying to see if we find people that we believe that are identical. And this is a good hint to start to understand how you and the match you are looking at are related. So in this example, I can see Moshe Zren, which is my grandfather, and it has a smart match with Moshe Zren, which is in Eric family tree, which is his great uncle. So that's a very good hint for me to know that this is the same person. I can review the information and see how we are related. Next in line, we have shared ancestral surnames. And these are very useful because while I'm looking at my DNA match, I can see the list of surnames of my ancestor, such as grandparents, great-great-parents, etc. And they play a vital role in the family history research. So we identify the surnames that you and your DNA match have in common to bring this to your attention. An ancestral surname that you and your match share could point to the identity of shared ancestor from which both of you inherited the same DNA segment. So I can see, for example, that with Eric, I have the Zrian family name that is in common. Next, we have the shared ancestors places. Shared ancestral places refer to either towns or countries or US states, in case of USA, that appear in your family tree, as well as in the family tree of the DNA match you are looking at. And they are related to birth or death events of your ancestor. So I can see the event location and the ancestor name in both three, and that can point me to common ancestors. Next, you have your shared DNA matches. If the DNA match we are currently looking at does not have a family tree on MyHeritage, we will not be able to use genealogical information to figure out how we are related. But also solely based on genetic information that we have, we can try to gather these hints to find out. So what are shared DNA matches? Shared DNA matches are people who share DNA with both you and your DNA match, meaning both of you have the same person in your list of DNA matches. This is another way you can learn which side of the family your DNA match is on. So here is my new match, Josh, and on the list of shared DNA matches, we can see my mom, who has been tested with MyHeritage. So even if Josh didn't have a tree on MyHeritage, and I don't know how he's related to me, that's a very good hint that Josh is connected to me from my maternal side. And for some of your DNA matches, you will see this indication. This means that you, your DNA match, and that specific shared DNA match, in this case, David, all three of you have at least one triangulated DNA segment, which is a term that I will shortly explain. So as I promised, and you may have already noticed it, we can also view and add labels to shared DNA matches. And this is probably the coolest and most efficient way to use them. So we can see the label that is already associated with Josh, and we can see the labels that are associated with our shared DNA segments. When you click the checkbox on the shared DNA match card, and you can click more than one, you remember, the labels pane will open on the side. So you can assign labels to multiple shared matches at once. So for example, if we saw that Josh is a relative of mine from my maternal side, I can add this label to him and to other shared matches that I conclude that are related to me from my mother's side. And once I apply, the match become associated with this label. And I will see that also on my shared DNA matches list, like here. Below the shared DNA matches, we'll show you a pedigree chart of your DNA matches. Pedigree chart shows the direct line of ancestors of that person, meaning parents, grandparents, great-great-parents, and so on. Looking at the chart of your match is especially helpful when looking for common ancestor or common names. They can provide you an idea of how you are related. So you can switch between the pedigree chart of your match and yours, so it's easier to check if you see anything familiar. Next in line, it's the shared ethnicities and genetic groups section that compares the ethnicity estimate of your DNA match to your own, so you can find similarities. So you will see the exact percentage breakdown of your ethnicities side by side with your DNA match's ethnicities. And those you share will be highlighted in purple. For example, I am around 17% Italian, and I know that my Italian roots are from my maternal side. So when I'm looking at Shmuel here, that also has an Italian ethnicity, that's a good hint for me to decide to start exploring this match on my maternal side. Now, the genetic groups that you see at the bottom, as I mentioned earlier, provides a higher resolution of geographic regions. So you can see if you have in common with your match. Okay, the last tool in our review DNA match page is the Chromosome Browser. And the Chromosome Browser takes the amount of shared DNA that you have and the number of segments and shows it to you. On the Chromosome Browser, it's reflected where on the 22 autosomal chromosomes, which we use to determine the amount of shared DNA that you have with other people tested on MyHeritage, where we found those identical regions on the chromosomes. When we are looking at the raw DNA data, we're trying to match it with the DNA data of other people who tested. We're trying to look for genetic sequences that repeat and that are long enough so that we'll have the tendency to believe that they are coming from a common ancestor. As you can see in this example, that's one chromosome. We have two pairs for each chromosome, one from our mom, one from our dad. And when we find the sequence that repeats between two people, like you see here, it's the purple areas you see on the Chromosome Browser. So let's talk a little bit about triangulated segments, which I mentioned before, and what you can do with them. So triangulated segments are shared DNA segments that you or a person whose DNA kit that you manage and all of other selected DNA matches share with each other, and therefore likely all inherited from a common ancestor. So you can compare more than 3 people, and we'll say that in a second, and try to see whether all of you are descendants of a common ancestor, and whether all of you are also matching in the same spot, the same position on the chromosome. Let's look at this example for how we inherit segments from our common ancestor. So in this family tree, we have 4 people who have taken a DNA test: Carol, Alice, Bob, and David. And we want to see who among these people will share DNA with one another and whether some of them have a common ancestor. So in the case of Carol, Alice, and Bob, they all probably share some amount of DNA which was inherited from William and Sandra, because they are all descendants of William and Sandra, and probably all of them are DNA matches to one another and have inherited some parts of their DNA. Another group that we can see here are Alice, Bob, and David, who are all descended of Eve and Zelda. And similar to what we saw with the first group, here we should expect to see also DNA shared between the 3 of them. But if we try to compare all 4 of them, we probably won't be able to find a DNA segment which all of them have in common, since Carol, David, and David at least, according to this family tree, do not share a common ancestor. Now let's see that with examples using the Chromosome Browser. So the Chromosome Browser can be used from the Tools section on your DNA results. You can click on Explore, and you will get to a new page where you can add up to 7 DNA matches and see whether these matches all triangulate. In this demonstration, we will see examples from my colleague Ron, who was happy to share that with us. So from here, you can look at your DNA matches and you can search by the names. You can add them and compare to see what the results will look like. For the first example, let's start with Ron's dad and his grandma and see whether the 3 share DNA, which we expect to happen. We should share about 50% of DNA with one of our parents, our dad or our mom, and about 25% of DNA with our grandpa or grandma. And dad and grandma should share 50% between them also. So when comparing, we see the colored line, which represents the shared DNA we share with that person. The shared DNA segments with each person are highlighted by color. So in this example, red areas are for the first person, and the orange areas are for the areas of the second person. The segments that are marked with bubbles are the triangulation segments, where all three people, Ron, his father, and his grandma, match. The triangulated segments are the segments that all have in common and were likely to be inherited from a common ancestor. In this case, grandma. When we hover each one of these triangulated segments, information about these segments and the chromosome appear. This information includes the genetic position, where they start and end, and the size of the triangulated segment. You can use that information later on when you're trying to understand how DNA matches who you don't know, how they are related to you. At the bottom of the graphical part of the chromosome browser, there is a table summarizing what you could have seen if you hovered over the triangulated segments. The table actually summarizes the same information if that's easier for you to digest like that. Now, let's look at Ron, his grandma, and this person right here, Jackie, which is a DNA match that we don't know the exact relation to him and from which part of the family she is. Even though you see that there's an overlap in chromosome 6, the chromosome browser indicates there is no triangulation here. In this case, what it means is that Ron is sharing the yellow part of the DNA with grandma, what you see here, but the other part in green with Jackie. By looking at grandma and Jackie, there are no shared segments. That indicates they are probably not related, and the Jackie is from a different side of the family. The best example for overlaps with no triangulation is if you are lucky enough to test both of your parents. In this example, the red upper line is Ron's dad, and the bottom one is the one he matches with his mom. So you can see they don't have any triangulated segments because Ron's mom and dad are not related to each other. And here is an example of how to use the chromosome browser when getting a new DNA match. In this case, we have Gene Feldman that doesn't have a family tree on MyHeritage. And unfortunately, we cannot use genealogical information to understand how he's related. So let's examine that with the chromosome browser. Let's start by adding a known relative, such as mom, and the new DNA match that we are exploring, Gene. By comparing, we see there are no triangulated segments in this case, and it probably means that Gene is not related to one from the mother side. So let's reject this assumption and move on. Now, let's add instead Ron's dad to our comparison. And now we see we have 7 triangulated segments in this case. In such case, we can assume that Gene is related from that side. The next step will be to compare Gene with grandma from that side. And now we see there are no triangulated segments. So we are going to assume for now that Gene is related from grandpa's side, not from grandma. Now we can take other cousins from this side of the family that we tested and check for shared segment and understand how Gene is related to us. Okay, now let's move on to the AutoCluster tool, which I'll demonstrate how it can help you. AutoClusters is a tool that helps you organize your DNA matches in a group manner. And you can generate AutoClusters report from here for you or for other kits that you manage. Let's start with what are AutoClusters? AutoClusters help you organize your DNA matches into shared match clusters that likely descended from a common ancestor and belong to the same family branch. After generating the AutoCluster report, you will receive a report that looks like this. And in the top section, you will see how your matches are sorted into groups displayed in different colors here. What are those groups? They are groups of people that originated from your list of DNA matches, and the algorithm is taking each of your DNA matches and looking at the shared DNA matches you have in common. So the resulted groups are basically groups of people who share DNA match with one another. Let's go back to Ran. Ran has matches called A, B, C, and D, who all match one another. On the other hand, Ran has also 3 more DNA matches, E, F, and G, which match one another, but they do not match with the people from the other group. One explanation for this might be that these groups of DNA matches are related to one from different ancestor. For example, A, B, C, and D are related to him through his father, and E, F, and G are related to him through his mother. So these are 2 groups of matches. So each cluster in your AutoCluster report groups together your DNA matches who share DNA matches with another. And for each cluster, the report will show you the amount of people that are in the cluster. If you also hover, you can also see the names of the people that are in this cluster. Now, let's zoom in to look at one cluster. Start with the first one. You can see the name of the people who are your DNA matches, and you can see who matches with who. The colored cells are the intersections indicating that the 2 people match. Our algorithm checks for each person that he matches enough people in this cluster and concludes that he is part of this cluster. The AutoClusters guide me to look for the people in this group and what ancestral line I should pursue, that probably all these people are related to me through. Sometimes the cells are not colored, but appear empty. In this case, these 2 people do not match one another, but since each of them matches enough people from this cluster, then the algorithm decided to put them together in this cluster. Sometimes there will be gray cells. Gray cells indicate two people that are probably can fit into 2 clusters. In this case, the 2 people match, but they fit both in the orange cluster and in the green cluster. So, as we said, the clusters of DNA matches are a good hint that these people are related to me through a common ancestor. These are from ancestor A, B, C, etc. And that's why it's really useful to look at those DNA matches all together as a group. Now, if you scroll to the bottom of the report, you can see these clusters in a table view, which will list you their names, information about the segments that you share, the cluster they are part of, and the size of the family tree they have on MyHeritage. You can also sort and filter the list by clicking on these links of the name and the family tree. You can land in the review match page or in their tree. Okay, and with that, I will conclude our session today about analyzing DNA matches. I hope you all enjoyed and thank you for your attention. If you have any more questions, I invite you to visit MyHeritage Help Center or the knowledge base that has much more information. Thank you, everyone, and bye.